Once again, I do not own any of the rights to this. Copyrights are owned by the Indiana University trustees and the McNeil LLC. Authors still haven't changed, and this is still Chapter 1, but Section 3, which covers the research methods. So, 1.31, how do psychologists study behavior? Well, that depends on whether their purpose is to describe, explain, predict, or change. This introduction to research methods in psychology is intended to do just that, introduce you to the ways psychologists study behavior. Although more than half of psychologists are engaged in applied practice, i.e. changing behavior, the evidence that guides their interventions comes from behavioral research. Psychologists are scientists. They are searching for answers to questions and solutions to problems. Research methods are the indispensable tools of their investigations. Like any skilled worker who uses tools in his or her profession, psychologists know which tool to use for their job at hand. A simple and useful way to think about research methods is to imagine a 3-tiered toolbox. We will begin with the research paradigms, the top level, which are aligned with certain methods in the middle level, which are aligned with certain statistics at the bottom. So, ways of thinking about science. Paradigms. Paradigms are the first thing you see when you open the toolbox. There's a reason you find them just under the lid at the top level. To know the reason, you need to know what a paradigm is. Any ideas? What if I told you that your family has a paradigm? Would you believe me? How about large corporations, small non-for-profits, or medium-sized places of worship? A paradigm is a set of beliefs or assumptions that is shared by a group. The beliefs don't even have to be written down for everyone in the group to know them and act in accordance with them. Psychology is guided by 2 prevailing paradigms for doing science, constructivism and logical positivism. It is very likely that you carried out some type of science project during the middle school or high school years. You didn't know it at the time, but you were operating from the point of view of one of these 2 science paradigms. Let's look at one at a time. So first, constructivists. Constructivists believe that our knowledge about anything is built. It's constructed as we go, and therefore it's a part of our experience. There is no single truth that applies to everyone's experience because each person's reality is uniquely his or her truth. The role of scientists is to observe behavioral phenomena as they unfold and to describe it and the experience of it. The process of making observations is bound to be subjective, and as much as the scientist is a part of the process. The constructivist paradigm addresses the first goal of psychology, to describe behavior. But then you have logical positivists, which is the second paradigm. So logical positivists believe that behavioral phenomena exist independent of the observer and can therefore be studied objectively. The purpose of science is to discover the truth, the laws of reality that operate independently of our observations of them. Logical positivists test hypotheses by designing experiments that seek to separate the effects of causal factors from extraneous ones, lest the truth be concealed or distorted. Other researchers try to replicate the findings, which is further evidence of the truth. The process starts with the existing theory or idea, makes prediction based on the theory, designs a study, tests the hypotheses by gathering and analyzing data, and then draws conclusions based on statistical findings. The results are then shared with the scientific community and the world. This process should be or sound familiar to you. It is the scientific method. The positivist paradigm addresses the second goal of psychology, which is to explain behavior. Researchers determine the most fitting research method based on their guiding paradigms and the research question they pose. Let's look at the next level of the toolbox. You will find 3 main methods there. Ways of doing science, research methods. Methods of doing anything from singing to surgery are techniques that, if used properly, achieve the desired goal. Methods are not ends in and of themselves, but rather they are means to an end. What are the implications of that statement? Well, if the person using the method has not asked what his or her goal is for using the method, the outcome is often bad or junk science. So often methods become more important than their reason for being, and that can be said for the introductory to psychology as well. At this point in your education, what is most important is that you understand why we have different methods, what each method can accomplish, and how it does that. So first we're going to start off with descriptive methods. The first goal of psychology is to describe behavior, and this is the focus of descriptive research. These methods focus on what is happening in a person or group. However, it is important to remember that this is the full extent of what descriptive methods can do. They cannot explain how or why or even when things occur. There are 3 different common descriptive methods used: naturalistic observation, case study, and survey. Naturalistic observation is a research method that places the researcher or observer in the natural habitat of the observed, which provides an opportunity to witness and record the behavior directly without interacting with the observed. It is, however, difficult to observe behavior without actually affecting the behavior by your very presence. The lifelong work of Jane Goodall exemplifies this research method and the challenges it poses when studying and becoming a part of the social interactions of chimpanzees in the wild. Then you have your case study, which is a research method whereby the researcher gathers a great deal of information about one person through a combination of techniques including interview, history, and review of records. Usually the subject of the case study is a person who exhibits behaviors that are of interest to the researcher. Though much can be learned about the behavior of one individual through case study, the findings cannot be extended or applied to other individuals. Despite its drawbacks, Freud relied exclusively on the case study, and even today, much of the practice of medicine is influenced by case studies. Survey methods are able to gather a lot of information about a lot of people by asking them to respond to questions about their behavioral practices, beliefs, or opinions. Surveys conducted on samples of a population have the ability to make predictions about the larger group, but only if the survey items are well constructed and the sample is a representative random sample. Next, we have correlational methods. Whenever we go beyond the first goal of science, which is to describe behavior, we are venturing into the realm of explanation, wherein we can focus on how something works or even why it happens. Descriptive methods shed light on the what of behavior, and in the process may lead the researcher to seek additional information that would explain how two items are related. If these things vary among some dimension, scientists refer to them as variables. Correlational research methods allow us to answer the important question of how are two variables related. This seemingly simple question is a powerful one because even though it goes only so far in explaining behavior, it opens the door to many other questions and methods that have the ability to answer why. In a way, correlational methods have a foot in each paradigm, and as such, serve as a bridge connecting them. Before we go too far ahead of ourselves, let's think about the way in which things that vary can be related. As we do, consider just a few of the many variables in the lives of college students, from the most mundane to the most significant: mood, study, sleep, attentiveness in class, friends, tardiness, alcohol, employment, and exams. For the purposes of explaining and illustrating how correlation works, choose any two. Back at the question at issue, in what ways can these and any two variables be related to each other? Well, one, they can vary in the same direction. Say you chose to study alcohol use and tardiness. Each of these variables varies along many dimensions, so we'll use just one for each. Alcohol use varies in frequency of use, and tardiness varies on how often it occurs. Let's say we conducted a research project to investigate the relation between alcohol use and tardiness. We asked hundreds of college students to record their frequency of alcohol use over the course of several weeks. During the same period, they recorded tardiness also increased. This is known as a positive correlation. The variables are changing together in the same direction. Let's try another two variables, this time sleep and attentiveness in class. For this research project, we asked students to self-report their hours of sleep over the course of several weeks, and we also observed and recorded their attentiveness in class over the same period. We found that as hours of sleep decreased, Attentiveness decreased. What type of correlation do you think that is? Are the variables changing together in the same direction? Yes, they are, and therefore it's a positive correlation. Don't let it throw you off that they're decreasing together. Decreasing together and increasing together are both positive correlations. If it's the same direction, then they're positive. Excuse me. So, 2. They can vary in opposite directions. Say you chose to study student employment and exam scores. Each of these variables varies along many dimensions, so we'll just use one for each. Student employment varies in the number of hours worked per week, and exam scores vary in the percentage of items correct. Let's say we conducted a research project to investigate the relation between hours per week and exam scores in all courses. We collected data from hundreds of college students, and we found that as hours worked per week increased, exam scores decreased. Are the variables changing together in the same direction, either both up or both down? No, they're changing in opposite directions. Yes, so therefore it's a negative correlation. 3. They can vary in no particular pattern, which means they are not correlated. Say you chose to explore studying and friends. Each of these variables varies among many dimensions, so we'll just use one for each. Studying can vary in how much time, and friends vary in how many. Let's say we conducted a research study to investigate the relation between how much time college students spend studying and the number of friends they have. We collected data from hundreds of college students and found that there was no relation between time spent studying and the number of friends. The absence of a pattern simply means that there are just as many students who study a lot and have a lot of friends as there are students who have little friends and study little, or they study little and have lots of friends. Similarly, there are students with few friends who study a lot and students with few friends who study little. There is a zero correlation, which indicates that two variables are not related. It does not shed any light on how the two things are related, except to say they're not. If you're thinking that positive, negative, and zero correlation seems to be mathematical, you're right. And as such, there's a numerical way to express them. Imagine a number line that starts at -1 on the far left and ends at +1 on the far right. 0 in the middle. Correlations are expressed by a correlation coefficient, which is the point on the line. What does this mean? Well, it means that if a number is closer to 1, such as 0.8, it's a stronger. What does it mean if it's closer to 0, such as 0.3? Well, it's weaker. And what does it mean if it's closer to -1, such as -0.75? Well, the most obvious indicator is the sign plus or minus, which corresponds directly to the number line and says whether the correlation is positive, negative, or zero. It is important to note that the sign of the correlation coefficient has nothing to do with how strong the correlation is. It merely indicates the direction of the relationship, positive or negative. The actual number tells you how strong or weak the relation is between the variables. The correlation is stronger as it approaches the extremes on the number line. It gets weaker as it approaches 0, hence a correlation of -0.8 is stronger than a correlation of positive 0.55. Is there a visual way to depict the correlation? Yes. Check the scatter plot exercise by clicking on the red link in your textbook, found on page 16. To be continued.